think I touched on this a little bit ago when we started Unit 1, and it had to do with compound word. Like when you were in kindergarten, you're learning your words. Well, a compound word, I need everybody's attention up here now. A compound word is when you take two words that exist on their own as separate words and make them one, like sidewalk, right? Okay, that's a compound word. This word plus this word equals a word itself. And when you are in first grade and your first grade teacher has you writing paragraphs, whatever that looks like to a 6-year-old, it looks like this. I like to read books. I like to do this. Remember this? And it's the most boring paragraph ever because they're not taught how to write yet. So it's I like. So then a teacher says, hey, how about we write a compound sentence? It means take two of your sentences and make them one. And what word do we usually use? And in English, you learn that that's called a conjunction, right? So how about instead of I like to read, I like to this, how about we write I like to read and I like to ride my bike? Okay? That's called a compound sentence. So today, we're going to talk about how to write and graph a compound inequality. So a compound inequality could start out as two separate inequalities. So if I said A is less than -1 and A is greater than or equal to -8, okay? We're used to graphing 1. We've graphed 1. If I said to you, hey guys, would you graph A is greater than or equal to -8 for me? You should not have a problem with that, right? Because we just did this, right? So you would take you take your pencil and you would say, well, here is A is greater than or equal to -8. Great, okay? But if I were to say, okay, A has to be greater than or equal to -8, but it also has to be less than -1. That would mean that you're graphing two inequalities on the same number line, and you're going to have to read that number line to see what that means. So here's -1. Here are all the numbers less than -1, and you have a graph that looks like that. Okay? So for and, the word and is really, really important because and means you have to do both. Like if I were to say to my kids, hey, Claire, I want you to take out the trash and do the dishes. And you don't get to pick. You got to do them both. Sorry, Charlie, bad day, right? Okay? Versus an or. An or would mean, hey, you could either take out the trash or do the dishes. You can pick. Okay? Yes, me too. So, ready? As I look at this, and I see that it's an and, I don't have a choice. Okay, let's pretend like we weren't in math class right now. If I were a Riddler and I walked up to you in the hallway of seats and I said, hey, what are all the numbers that are greater than or equal to -8 and also less than -1? What would they be? How many numbers are we talking about? How many numbers does our solution set actually contain? It could be what? Yeah. Yes, so and -8. So she's saying, it could be -8, -7. I'm going this way, -6, -5, -4, -3, and then she knew to stop at -2 because it can't be -1. What's your question, Daniel?
I just noticed that you put them in the wrong places.
Nope, -1.
-8 and -10 should be zero.
That's 0, sweetie. 0, 0, 0.
Then what's that other thing that's
What line?
right there? It shows -1 and then 0.
This is 0 on a number line. That's -1, which is to the left of 0. Okay, we're going to move on. So if I were to ask all of these, what are the solution sets and what they could be, it's these numbers. So how does a graph help you realize that? Do you notice anything about this area here? How it's got a blue line and an orange line? We're going to call that the overlap. In an and, I'm looking for overlap because it fits both inequalities. So the numbers that have blue and orange, That's my solution set because it fits both inequalities. So some people actually get fancy and they kind of say, well, if this is -8 and this is 0 and this is -1, I know that it has to be greater than -8, but that I have to stop at -1. So sometimes they'll write it like this, okay, without these little extra arrows. You don't need those. You know why? Because the numbers that are on the blue only satisfy the greater than -8 part, right? And the numbers that are only orange satisfy the only negative, less than -1. I want overlap. So now here's my next question. Do you remember how to take these two inequalities and write them as a compound inequality? Okay, here's the deal. It's like the I like. Right now this exists as I like to ride my bike. I like this. You only get to use I like once. You only get to use A once. So how do we write this? You have a decision to make here. I kind of like to put the numbers, kind of like Daniel was thinking earlier. It just makes sense to put the numbers where they are in relation to each other on a number line. So isn't -8 to the left of -1? Yeah. Okay. Let's say you aren't really thinking and you're just kind of throwing numbers down there and you put the -1 over here and the -8. It's not going to be wrong. You just have to adjust something. I like it this way. Here's why. I'm going to cover the -8 up. When A is first, I'm just going to really just bring that symbol down. Okay? Here's going to be the other thing. Now I'm going to cover up the -1, and in our original problem, where was the nose pointing to the -8? So it had still better be pointing that way. Hint, hint. They had better both be pointing the same direction if you're talking about an in-between. If you chose to write it that way, fine. If you chose to write with the -8 here, 8 is what? And then they're both going to go this way. You'll see them both ways, please be aware. So whether they both go left or both go right depends on your placement of your numbers. Are you with me? Okay? So if I were to, that was our and, okay? If I were to say, hey, give me a number less than or equal to -5. Or you know what? If you don't like giving me numbers that are less than or equal to -5, that's okay. You don't have to give me one of those. Give me one that's greater than 0. So now let's talk about or. Or is different. Or means it doesn't have to fit in both. It means pick one. So what does this look like in terms of my solution set? It looks like me taking 0, -5. Here are all the numbers that are less than or equal to -5. Here are all the numbers that are greater than 0. And that's my answer. So here's the thing though. This is a good graph for this, but every now and then I'm going to ask you to kind of think a little bit higher order. Meaning if I say graph this, sometimes it's easier to say what the numbers cannot equal as opposed to saying what it can equal, right? So 1, 2, 3, 4, 5, 6 forever and ever and ever would be okay. You don't want that one? -5, -6, -7, that would be okay. Are there any numbers that x could not equal? James? Yeah, not equal.
You have -4, -3, -2, -1.
Yeah, -4, -3, -2. It can't be, it can't be 0 either. -4, -3, -2, -1. And because 0 is not colored in, it can't be. So that is an acceptable answer as well. This is sufficient. However, I need you to be kind of practicing this because when you get to questions like this on the PSAT, that might not be an answer choice, but that might be. So I need you to look at it in terms of what your solution set does contain, but also what it does not contain. Are you with me? Okay, so that was the graphing. Now let's write them, okay? So I'll have these for you, Daniel. I'll give them to you after. All right, so if I were to say, I'm going to give you that good old verbal sentence. All numbers that are less than 3 and greater than negative 2. So here's the deal. In a perfect world, they'd come right out and they would give you the inequality and go, boom, graph it. Well, shoot. They're going to give you a sentence that you have to turn into the inequality, then you're going to graph it. So I'm adding one step above it. So let's go ahead and you know what? It might be easy. It might be helpful to write them as two separate and then combine them. Because a lot of kids kind of have to be able to, they can write them separately. Meaning, let's write this one. All the numbers that are less than 3 would be this. Right? Pretty simple. All the numbers that are greater than negative 2 looks like that. If you can get to the combined inequality, just like you have a combined sentence without having to do this step, you go right ahead. I think a lot of kids have a hard time doing that though. So if x is in the middle, I want to put my negative 2 here and my 3 there. However, if you want to put them in the order the problem was, that's okay. Your inequality signs just have to match that. So I'm always going to cover up the left one. Why? Because it's easier to read inequalities when the x is on the left. So what is x compared to 3? It says it right here. So I literally just take this sign, and as soon as you find the direction of one of them, you're good. You know why? Because they have to match in this case. So then I know that this goes. But why is this backwards? Why is it greater than here? Oh, it is greater than here. The x is just backwards. You understand that, right? Okay, so take this verbal sentence, create 2. If you can go right to this from the beginning, great, go for it. All right, and so now we're going to graph that. And if this is 0, this is negative 2, and this is 3, go ahead. And you know what? You can decide if you want to have those arrows flapping off the ends or if you whatever. So x is less than 3, but it also has to be, it's kind of like I'm going. Ooh, I got to stop because it has to also be greater than negative 2. Do you see your overlap? Okay? So in this case, if I were to say, so give me all the numbers that x could actually equal, meaning I'm looking for overlap. What are all my values? Could x be negative 2? No, because that's colored in. Could it be negative 1? 0? 1? 2. That's it. Right? You with me on this? Okay, so I'm looking for overlap. Let's take a look at this one. All numbers less than 0 or greater than or equal to 2.
I can't do this kind of
Okay, thank you, Jacob. All right, there's the words. Write it, then graph it. So, it's an or. The first thing you need to know about an or is that, and you need to write this in all caps and circle it and put a big star by it, because this is going to haunt you, because it's haunting some other kids. Ors cannot be written combined like the ands. The ors have to stay separate. And you're like, awesome, because that's the hard part anyway, right? Ors must stay as two separate inequalities. You cannot combine them into that. Okay? Piece of cake then. So all I'm doing is taking this one, which is less than 0, and putting it here. Then I want to take this next one, greater than or equal to 2, and put it here. I can't combine it because it's an or. So in an or, am I looking for overlap? No, because it doesn't have to fit both. It only has to be one. If you don't feel like giving me a number less than 0, fine, don't. Give me one greater than or equal to 2 then. So now let's see what this graph looks like. This is going to be interesting. So if this is 0 and this is 2, here's less than 0 here's greater than or equal to 2. There's only 2 numbers that you can't say, right? If I say, give me a number greater than or equal to 2 or less than 0, every number would work except what? 0 and 1. Why not 0? Because it's not colored in. Why not 1? Because you know what? Look at where the blue line is. All the numbers on the number line under the blue umbrella fit this inequality, so they would work. All the numbers on the number line that match up with this orange would fit this. 1 doesn't belong to anything. 0 doesn't belong to anything. So you could say all numbers except, you could say the word except 0 and 1, or you could just say A cannot be 0 and 1. Okay? Let me just point something out to you. There are 3 ways to write this answer. Here's your first way, which is the good old-fashioned inequality sign. Okay? Second way is go ahead and use that, like writing the word except. Or the third way could just be saying, hey, here's what it can't be, using the not equal sign. Okay? I want you to, for right now, attempt at least this way and this way. Now, here's the deal. If you have one that goes all the way from, like, you know, if you got negative 100 here and positive 300 here, and it's going like this, do you have to say, oh, it can't be negative 99, negative 90? No. If you're talking about like a handful of numbers, like 5 or 6, then take it that one extra step and tell me, oh, just can't be those 2. If you're listing 50 numbers, forget about it. If that's the case, that is plenty right here, okay? So that's kind of the deal with that. All right, so that is writing and that is graphing. Next, we're moving into solving.